Have you ever seen something like this, where no matter how much you zoom in, there never seems to be an end to it? Well, they're called fractals, and an example here is the Mandelbrot set. I recreated it using Pygame and NumPy. First of all, how do we get the Mandelbrot set? So this is the complex plane. We got the real numbers here and the complex numbers on this axis. So let's say there's a point here, then the distance from the origin to this point right here, this point, this distance is called the modulus. We can define this point by, let's say, 3 plus 4, no, 2i. Yep. And we can call this number z. So we got z0 equals 3 plus 2i. And we can use this equation here and find the next value of the point by squaring that number and then plus a constant value. This should be c, not z0. C as a constant. And then whatever number this equals, we plug it into the equation again. So z2 is equal to z1 squared plus c. And then we plug this into here again. So z3 is equal to z3 is equal to z2 squared plus c, blah blah blah. So we do it over and over again, and every time we check the modulus, which is distance from the origin of each z number, check if the distance is less than 2. If it is less than 2, then we get the Mandelbrot set. So we can plot the z and c as values along the real and complex plane. And then we can map its color by how long it takes for the number to diverge into less than 2. And we have a max iter, so we can do all these steps for like 200 times. The lower the number of iterations, the less defined it's gonna be, but it will run much faster that way. And if you set it to like 1000, then it's gonna be really high definition, but it's gonna take forever to run. So I made a demo file here to understand it easier. You can define a complex number in NumPy using the j value instead of I. Next, we can define this function of squaring z and adding the constant. Then I defined a function to find a new z value for n number of times until either the modulus becomes less than 2 or we run out of n. So as you can see, I tried quite a few values here to see which ones belong to the Mandelbrot set, and after a while I got one. It only took one iteration for the z value to become a part of Mandelbrot set. So I'm not gonna waste your time any further, and here's the demo. So you can see I have to increase the max iteration to load more details, because as you zoom in, distance between the Mandelbrot set values gets smaller, so it has to run a bit longer to get the values for it. And it gets to a point where I can't load it any further. Around here, I started messing around with the screen. The more pixels we have to render, the longer it takes, so you can't see it clearly, but it's really laggy.
Jasmine, I dare you to create.
I also messed around with the code a little bit. I changed the modulus threshold from 2 to 10 to see what difference it makes. And it created this weird sort of mini Mandelbrot in the left line here. And then as I zoom in more, the shapes just turn into a kind of insect. Now when the modulus threshold is 200, instead of a mini Mandelbrot, it is like a star-like polygon, and then as I zoom in more, it turns into a mini Mandelbrot again. It was pretty fun to mess around with these beautiful fractals, and the code is on my GitHub page. So thanks for watching. I'll see you in the next video.